So looking ahead, today we'll do double angles. Block day we'll do half angles. Friday I'm not here, so I will leave you with the review to do, so you already have it. So Friday will be all yours to work on the review together, and then Monday I'll take questions from the review, and Tuesday we'll test. So it lays out quite nicely to have 2 review days, especially if I'm out the first review day. Are there questions from? What questions would you like me to answer from worksheet 2? The sum and difference with drawing pictures. Number 3?
Yeah.
B, number 3. 3 in general then. That's a good one because it's 2 pictures, they're both negative. It gives it the most complicated way to give the angle with that not in quadrant 4 thing. 1 sine, 1 tangent. So yes, if we'll do number 3, we'll be pretty good. Thank you. All right, again, you got to get the picture right or else the rest won't really matter. Given that cotangent of m is negative 5/12, sine of n, okay, I don't care about n right now. The cotangent of m is negative. All students take calculus. So cotangent is negative in the
First or fourth, it can't be fourth.
second or fourth,
It can't be fourth.
but then it can't be fourth, so it has to be the second. So in my mind, that's the trickiest way to give you an angle. First, it's cotangent, which is a little bit weird, but then it tells you this not in quadrant 4, so you have to really think about, well, it could be in 2 and 4 because that's where cotangent is negative, but 4 is out, so it's got to be quadrant 2.
The numbers aren't going to matter. It's just the sign of it being plus or negative, and then cotangent, tangent, etc.
For determining quadrant, yes. The numbers don't matter for quadrant, just the sign and the trig function. Okay, so toa. So cotangent is the flip of tangent. So the adjacent is 5, the opposite's 12. Where did the negative come from?
5.
The 5, because it's backwards. Okay, so I've got angle M drawn out, ready to go. Now for angle N, sine is negative in the 3rd and 4th, but can't be 4th, not in quadrant 4, so it has to be in quadrant 3. So toa, so opposite over hypotenuse. The 3 is negative because it's down. What's the missing side in this one? Negative 4 because it's backwards. And what's the missing side in the other one? 5, 12, 13. Okay. So now my problem is all set up. Now I'm just using formulas. So it should be easy. Maybe not easy. Straightforward anyway from here. So the sine of m minus n is the sine of m cosine of n minus cosine of m sine of n.
So the sine, cosine, etc., that stuff doesn't have to relate with what the graphs are on the top?
No, like this is always true. Now I'll go to the graph to fill in the pieces. So the sine of m, sine is opposite over hypotenuse, so that's 12/13. Again, it's not the sine of 12/13. The sine is 12/13. Cosine of n, so make sure you're looking at n. Cosine is adjacent over hypotenuse, negative 4 over 5. Minus negative 5/13. Negative 3/5. So negative 48 over 65.
Minus 15 over 65.
Minus 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 means minus.
Yeah,
15 over 65.
Negative 63 over 65.
So that would be negative 63 over 65. So draw the picture right, and be careful. Be careful. Like that's it. Draw the picture. Be careful. Be careful drawing the picture. Be careful with the formula. Be careful grabbing the sines and cosines. Be careful with the algebra. Be careful with the signs. Be careful multiplying. Like nothing in here is that hard, really. It's just there's a whole bunch of places to be careful at. Especially with tangent, because it's a little bit trickier. Tangent of m minus tangent of n over 1 plus.
So if it's a minus tangent problem like that one, it's going to be plus and 1 plus and 1.
Correct. But again, we will give you that formula, so you don't have to worry about it. It's just after I've done examples all day for a week, I've rememorized them. Maybe you're close to that as well. At least for some of them, anyway. Okay, tangent of m. So opposite over adjacent would be 12/5 negative. Minus tangent of n would be 3/4. And good, let's just call it positive 3/4. It's negative 3 over negative 4, but there's enough signs to keep up with. Let's just make it 3/4. Over 1 plus those same values. 12 over negative 5 times 3/4. Okay, our pre-cal work is done. Now we get to jump back to Algebra 1 and see if we can clear a fraction. What should we multiply by to make all of the denominators go away?
5.
Let's go 5 and 4. You could do negative, but that might be tricky to keep up with. Let's just do 5 and 4. So on the first term, the 5s will cancel. Don't forget the negative. Maybe I should have put the negative up top. But so negative 12 times 4. Minus, second term, the 4's cancel. 3 times 5. Bottom, first term on the bottom, nothing cancels, so 5 times 4. And then on the second term, the 5 and the 4 cancel. So negative 12 times 3. So negative 48 minus 15 over 20 minus 36. Negative 63 over negative 16. 63 over 16. It's a little bit of benefit of doing sine and or doing two trig functions of the same angle, m minus n. Like they're going to have some of the numbers similar, right? Because sine was opposite over hypotenuse, tangent is opposite over adjacent. So it makes sense that their numerators match because their numerators were both the opposite. Like you don't have to do that, but that's a little bit of confirmation that I feel good about this answer.
Could you go over the setup for number 2? Not all of it, just like the setup.
Picture.
Yeah.
Back to number 2.
Like with it being not 0 to 2 pi.
So where is pi to 3 pi over 2? What quadrant is that in? That would be the third. So opposite adjacent. But they're both negative. 8, 15, 17. That's triangle A. Triangle B, pi over 2 to pi, that would be in quadrant 2. Adjacent over hypotenuse. So there's triangle B, and then you're off and running.